Example 3, we're looking at the law of cosines. We're looking at applications of it. So we have a pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet as shown. The pitcher's mound is not halfway between home plate and second base, so we can't assume that that's 90 degrees. We need to find out how far is a pitcher's mound from first base. So this distance here, which they labeled as h. So we want to find h. We have two sides and their included angle. And so what we're trying to find is h. So let's write our formula first. So h squared equals f squared plus p squared minus 2 times f times p times the cosine of h. So then we just plug everything in. So h squared equals 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. So h squared is approximately 1800.33 feet. Then you take the square root, so that distance h is 42.43 feet. So try this second example. In a softball game, a batter hits a ball to dead center field, a distance 240 feet from home plate. The center fielder then throws the ball to third base and gets a runner out. The distance between the bases is 60 feet. How far is the center fielder from third base? So you can kind of use this here. So center field is going to be, so if it hits it directly straight ahead, so it's going to go through here. Third base is located here, in case you don't know a lot about softball or baseball. So that's third base. So it goes past this and goes to center field, and then they throw the ball there. So draw a triangle to kind of help you out, and then find how far is the center fielder from third base. Okay, so maybe the hard part was drawing the triangles that you have here. So we could use the information that we had before. So the batter hits a ball. So the batter usually stands in this position and then hits the ball to dead center field. So that distance is 240 feet. And then the center fielder then throws the ball to third base. Then the distance between the bases is 60 feet. So the 60 feet, that gives us this triangle here. So we know this is 240, this is 60 feet, and then we borrowed the 45 degrees from the previous problem. So then we have two sides and an included angle. So I wrote h squared equals 60 squared plus 240 squared minus 2 times 60 and 240, and then times the cosine of 45 degrees. So that is h squared equals 40,835.32, and the square root of that. So that distance is approximately 202 feet. So let's try this example here, an application of the law of cosine. So a ship travels 60 miles due north and then adjusts its course. So it's going north and then adjusts its course as shown in the figure. After traveling 80 miles in this new direction, the ship is 139 miles from its point of departure. We want to describe the bearing from point B to C. So B to C. So what we're looking for is this angle here, right? Because this is north, and then so we want to find what is this description. So we're looking at bearing. So we want to find is angle B right here. Because if I can find angle B, then I can figure out what this angle is here for our bearing. So that is a straight line, and so remember a straight line is 180 degrees, and so if we find out B, then we can figure out A. So B, this angle B, is across from 139, and so we have two sides and an angle, or we have three sides actually. So we can use cosine B. We have three sides, so cosine of B equals a squared plus c squared minus b squared over 2 times ac. Okay, so we have three sides, and we want to find the angle, and the angle we want to find is B. So let's plug in what we know. Cosine of B equals 80 squared plus 60 squared minus 139 squared over 2 times 80 times 60. So you plug it all in your calculator. Cosine of B is approximately negative 0.9709, or angle B is approximately 166.15 degrees. So B as 166.15 degrees, and if this is a line, then we can figure out this bearing. So what we do is we take 180 degrees minus the 166.15 degrees, and that gives us this angle here, which is what we want. That angle is 13.85 degrees. Okay, so we know that the direction is going in this here. So looking at the compass, so remember how to write this. So it's going north, so we're going to say it's north 13.85 degrees, and it's going west. Okay, so that is the bearing that we're looking for. So try this example here. A ship travels 40 miles due east, so it's going east, and then changes direction as shown in the figure. After traveling 30 miles in this new direction, the ship is 56 miles from its point of departure. We want to describe the bearing from point B to C, so we're trying to find this here, and so just see if you can figure out what we're trying to find, how to find bearing on this problem. All right, so this one you are still looking for cosine B. Cosine B is a squared plus c squared minus b squared over 2ac. Then you find that angle B is 105.37 degrees. Remember, bearing has to do with the y-axis or our north-south line, and so we're really looking for this angle here to the y-axis, right, which is our north line. So what you do is you take the angle of B, 105.37 degrees, and then you subtract 90 degrees, right? Because that'll give us this other angle right here. And so that ends up being 15.37 degrees. Now it's headed in this direction, looking at the compass. That helps us out. And so we know that it's traveling north 15.37 degrees, and east. So I hope this helps you out.